Hello folks, we are continuing with the exercise 3.2. This is the part 2 video. We are continuing with the problems where we were finding the other trigonometric ratios when a certain trigonometric ratio is given. So our third question is cot x equal to 3 by 4 when x is in the third quadrant. Third quadrant, cot is positive. So that is why we have a positive ratio. Now we have learned that the moment you are given a ratio, we will find its reciprocal ratio so that much work of ours is done. So because you are given cot x, we can quickly find tan x, and tan x is going to be 4 by 3, and it's going to be positive because it's in the third quadrant. We are clear. The third quadrant is dominated by tan and cot. Okay, so that is tan x is there with us. Now we have to find out the other trigonometric ratios. Mainly if you could find sine and cos in either one of them, if you could find, then you will be able to find all other trigonometric ratios. There are number of ways of doing it. You can take cot, take the identity, and from there get cosec, then get sine. It's all different ways, but we will be always resorting to, whenever we get tan, we will resort to the identity of tan in relation with sec, then get sec, and from sec get cos, and so on. That's how we'll be proceeding always. As I said, we'll keep a particular plan always fixed so that we don't beat around the bush and waste time. Right. So tan x is there with us. We know from the identity that we studied last year that sec x is root of 1 plus tan squared x. So that way, and what sign are we going to decide? Because it's in the third quadrant, sec will definitely get a minus sign. So it's minus, that it is going to be, it's a negative sign, and therefore let us see how this will come to 1 plus tan squared x. So it's going to be 16 by 9 for us. When we equate it into 9, it will come to minus root of 25 by 9. And literally when you take the root, it will be 5 by 3. So you are getting sec x as minus 5 by 3. So that allows us to get cos x. Cos x therefore becomes minus 3 by 5. That further allows us to get sin x. Sin x for us is going to be root of 1 minus cos squared x, where that will also take a negative sign because it is in the third quadrant. Now certain children, they are very, very good in Pythagorean triplets. You know, they know lots of triplets. 3, 4, 5 is a triplet. All the multiple of 3, 4, 5 are also triplets, like 6, 8, 10. You take any multiple, multiply this 3, 4, 5 with a certain number, all that you generate, they become triplets. Now if you're very good at triplets, actually you need not calculate this. 3, 4 and 5, they are triplets. So if 3 has come in cos, 4 will come in sine. You know, if you have that thing in mind, your calculations will become fast. If we don't have it in mind, fine, we can do the calculation and get the answer. So let's have this. It's minus root of 1 minus 9 by 25. Yeah, it's 9 by 25. So like that, when we equalize into 25 minus 9, it's going to be 16, root of 16 by 25, which in effect it is going to be 4 by 5. So you've got sin x as minus 4 by 5, and that's how you'll get cosec x as minus 5 by 4. Are we done with all the trigonometric ratios? Yes, we have got 1, 2, 3, 4 and 5. Right, pretty hassle free, quite easily we got it. Now we go to question number 4, and let's check what the question number 4 says. It says that sec x is 13 by 5 when it is in the fourth quadrant. That's good. Sec x is 13 by 5 when x is in the fourth quadrant. Right, so x is in the fourth quadrant. So in the fourth is dominated by sec and cos. So that is why sec is positive, right? So the moment you have got sec, it's customary to write cos, and it's going to be cos x is going to be 5 by 13. It's going to be positive because it's in the fourth quadrant. Now moment you have got sine, we are tempted to get the moment you've got cos, we're tempted to get sine, but because it is in the fourth quadrant, this will definitely take a minus sign. So we will take it will find the negative of this. So it's minus 1 again. If you were little aware of the triplet, these answer will be direct. 5, 12, 13 is a triplet. So if 5 by 13 is coming in cos, 12 by 13 will come in sine. We can have it that way. If you don't know it, we will substitute and find out. Cos squared x is going to be 25 by 169. And when we solve this into 169, when we solve this, this comes to 169 minus, the minus sign is there, 169 minus 25 by 169, it comes to 144, root of 144 by 169, which is minus 12 by 13. So you're getting the sin x value as minus 12 by 13, and once having got this as minus 12 by 13, we can also find out what is the cosec. So the cosec x, because it is in the fourth quadrant, is going to be negative, and it is 13 minus 13 by 12. Now having got this, we can, it is customary to find tan x by taking the ratio of sin x and cos x. So we can have sin x by cos x. Sin x for us, it is minus 12 by 13, and cos x for us, it's 5 by 13. The 13 and 13, they can cancel each other, and you're getting minus 12 by 5 as the tan ratio. That allows us to get the cot also, and the cot ratio now comes to minus 5 by 12 because it's a reciprocal ratio. So we've got all the other ratios 1, 2, 3, 4 and 5. So this is about the problem number 4, where they had given us a sec ratio, and we found out the other ratios from there. Remaining questions, similarly, we are taking it up in the next video. Thank you.